Today's lesson, as you can see in the slide, is about two topics. No, the first one is a very short one. It's called group isomorphisms, um, and the second topic is about subgroups. Group isomorphisms are essential in the study of algebra to distinguish one group from another group. No, sometimes two groups are not necessarily equal, but sometimes they tend to behave, the elements tend to behave similarly, no? And this can be established formally using the concept of group isomorphisms. To give you an idea, ano ba sinasabi ni Sir doon sa sa term na isomorphism, I would like you to consider this example. Okay? So suppose that you have the set G, and then the set G has the following elements: I, R, A, and L. Now, I, R, A, and L they represent military commands. Kapag, di ba, yung sino dito naka-experience mag-ROTC or something, military training, no? So anyway, hindi naman kailangan ng military training to understand the following commands, no? Kapag sinabi ng commander, attention, you just stand up straight without doing anything. Okay? Pag sinabing right face, you're going to turn yourself 90 degrees clockwise. Tama ba ako? Right face, 90 degrees clockwise. Pag sinabi namang left face, you have to turn your body, you have to turn yourself 90 degrees counterclockwise from where you are, standing. Okay? And of course, pag sinabing about face, sa Tagalog, ito yung tatalikod ka. No? So you're going to turn yourself 180 degrees, whether you do it clockwise or counterclockwise. Pero normally in ROTC, dapat clockwise ito. Basta it's a half turn. When you say half turn, a 180 degree turn. Okay? So the set G contains all of these commands. So imagine niyo yan yung elements ng G. Now on G, i-define natin yung composition of commands or composition of functions. Again, kapag sinabing composition, you do the one you do the next one following after doing the other, no? So for example, pag nakakita kayo ng R circle A or R composition A, it means to say that about face, ikaw ay mag-about face muna to be followed by a right face. I-execute mo muna yung about face, then from that position, after doing the about face, ikaw ay mag-right face. So you can think of, let's say, ito yung katawan mo, sabihin na lang natin square, no? And let's say, this is your face. You're facing in that direction, okay? So if you apply an about face command, ang itsura mo na after executing the command is like this, no? And then, if that is followed by the command R, no, if from that position, ito yung position mo na, current position, magra-right face ka, what is your final position? Your final position will be, so from here, pag ikaw yung nag-right, pag nakaharap ka dito, ang left mo ito ang right mo, di ba? So, ang right face is going to be like this. Naintindihan nyo ba? Do you understand what I'm saying? Okay. So, the composition R circle A means the summary of these two commands. When you say the summary, ito yun. So, yung R circle A, sorry. Okay, so R circle A, relative to your original position, this is your original position, your final position is like this, no? So you can therefore say that R circle A is actually a left face command. So if an about face was followed by a right face command, in summary, that is just a left face command. So we can say that R circle A, or you can say R times A is equal to L. Do you understand? Now, what we're going to do is we're going to fill in the table no? So ito yung composition IRAL, IRAL. Of course, first of all, because I is the attention command, you will not do anything after, after marinig nyo attention. You just stand straight. If you compose it with something else, with some other commands, it will give the same command. So for example, two attentions will give you an attention. Attention circle right face. Pag sinabing attention circle right face muna bago attention. So therefore, that's R. A, L, no? Even when you multiply R circle I, that's going to be R, A, and L. Next, how about two right turns? Ano yung sabihin ng R times R? R times R, if you do two right turns, what do you get? Okay, very good. So that's going to be an A. Now, ano yung R times A? Ginawa na natin to. That's L. Now, what's R times L? Pag sinabing R times L, tatandaan nyo, ang unang ginagawa ay yung nasa kanan pag composition. This is read from right to left. So if you do a left face to be followed by a right face, of course, they will undo one another. So you are now in the original position. Okay. How about A times R? A times R. So that's right face followed by an about face, that's a left face. How about two about faces? If you perform two about faces, what do you see? Yeah, I. How about left face followed by an about face? Left face, nahihilo na siguro kayo no? Kung ginagawa niyo, that's a right face. Right face followed by a left face is right face, left face. Okay, that's yeah. How about face followed by a left face? Diba right yun? Finally, two left faces will give you an about face. As you can see, we were able to fill in the following table. Okay, and that's your table. Meron pala akong table para akong tanga, no? So bagay, anyway, at least nakita nyo kung paano ginagawa yung table. What you can see in the table is that actually this set forms a group under this set of 4 commands forms a group under composition of functions. Okay, why is it a group? First of all, composition is an associative operation. Remember that. Second, it has an identity element. The identity element is I. Okay. Now, how about inverses? What is the inverse of course, the inverse of I is I. It's the inverse of R. Anyone? What's the inverse of R? What will we multiply to R to get I? L. Of course, the inverse of a right face is a left face because they will undo one another. What's the inverse of a left face? Right face. Inverse of an about face? About face, no? To undo the about face, kailangan mag-about face ulit. Yun yung sabihin ng mga yan. So as you can see, everyone gets their respective inverses in this set. Therefore, this is really a group. In fact, this is not just a group. It is an abelian group, right? Do you agree? Do you agree that it is an abelian group? Okay. Thank you. Now, why did I give you these examples? As you can see, this group comes from an everyday life example, no? So ito ay kumbaga weird na makakita ka ng group basta-basta somewhere, no? But in fact, yan katulad yan, nag-exist ang mga groups sa paligid natin. We just don't know that they actually form a group, no? Kasi we don't think hard about these things. Pero kung titignan nyo, this is actually a group structure, a perfect example of a group structure. Okay, now, the next thing I want you to do is to consider this group table and compare it with the group table of the group of integers modulo 4 under addition modulo 4. That's the group Z sub 4. So, ayan, nire-write ko yung table nila side by side. And do you notice something? Would like to explain, no? I would like to share their observations about pinagtabi ko sila side by side, so therefore I would like you to compare. Would like to give their observations. Anyone?
Same lang po.
What do you mean same lang siya, no?
Ano po, para po yung IRAL po.
Oo.
Same lang rin. Kunwari po yung I po is 0, R is 1, A is 2, L is 3 po. Tapos yung
Ayan,
nasa loob
correct.
po ng group parang ganun rin po.
Very good. Sabi naman ni Ron sa chat box, parang may correspondence. Oo, kasi first of all, magkasing dami sila ng number of elements, no? Talagang may correspondence. Na-observe naman kanina, sino ba yung nagsalita kanina? I forgot to take note of the name.
Alistair po.
Yeah, si Alistair. Sabi ni Alistair, if you think of I as 0, R as 1, A as 2, and L as 3, you find that they are the same table, no? Only the elements are different from one another, but as a group, no, as a structure, they are essentially the same. I'm not saying that they are equal, of course. I'm saying that they are essentially the same in the following sense, no? Tingnan niyo, ito yung sinasabi ni Alistair. Halimbawa, yung I tsaka yung 0, you consider them equivalent. So, by equivalent, I mean I'm coloring them using the same color. And if I identify R as 1, no? And color them using the same color, and identify A and 2 together, and finally identifying L and 3 together, you can see the pattern in the table, no? And in fact, if you blindly consider the names of the elements, you just consider how these elements interact with one another as a group, you find that they are essentially the same group tables. Did you understand? Naintindihan niyo yung punto ko? This idea in abstract algebra is what we call an isomorphism. But technically, an isomorphism is a function, no? It is the function that makes the correspondence. Yung tinatawag niyong correspondence, yung I i-assign sa 0, yung R iisipin mo as 1, yung A iisipin mo as 2, yung L iisipin mo as 3. That function in abstract algebra is what we call as a group isomorphism. Now, if a group isomorphism exists between groups, we can say that the groups are isomorphic. We use the word isomorphic to say, no, that these groups are essentially the same. Now, to formally give you the definition, here is it. Here is the definition in the next slide. Okay. So we say that, so here in this definition, there are two groups, G and H. As you can see, G may be totally different from H in the sense that, first of all, the sets may be different from one another. No? Second, their operations, of course, may be completely different. No? Kagaya nitong huling example ko. Ang laman ng G, mga commands, mga military training commands. No? While yung Z sub 4, integers modulo 4. So, kung i-compare natin yung dalawa, this is a real life example. And the second one is an abstract example. The second one is an example that exists only in mathematics, no? Pero yung naunang example, this is an example that we see, that we can observe in our everyday life, no? Now, the idea of talking about isomorphisms is to classify groups up to isomorphism. When we say we wanted to classify groups up to isomorphisms, for example, yung dalawang groups na nakikita nyo na yan sa screen, we classify them as one. or we think about them as one example of a group. We don't think one as different from the other kasi they are just essentially the same. Kung bibilangan mo yung iba't ibang uri ng groups, isa lang ang bilang ng dalawa. Did you understand? So we are basically forming an equivalence relations among groups, no? Did you understand? Yung equivalence relation na tinutukoy ni Sir, yun yung pagiging isomorphic ng dalawang groups. Okay? Na anong ibig sabihin kapag ang dalawang groups isomorphic? Yan, ganito natin sinusulat yan. Parang congruent sa geometry. Di ba, halimbawa, ang dalawang triangles, hindi naman kailangang equal para maging congruent. Right? Alam niyo yun, di ba? Tama ba sa geometry? Ang dalawang triangles need not be the same to become congruent. Parang, halimbawa, you get parallel lines like this. Tapos, you get to intersect, you get a pair of intersecting lines, no? Kung parallel yung dalawang, tapos paano ba yan? Halimbawa, ito'y congruent dito, ito'y congruent doon, no? Yan. If that is so, then by SAS congruence action, you can say that this triangle is congruent to this triangle. Kasi nasabi ko, some relations in mathematics are weaker than just being equal. Kagaya nito, yung congruence among triangles is a weaker version of equality. Hindi kailangang equal para maging congruent. That's what I'm saying. Kagaya sa abstract algebra, hindi kailangan maging equal ng dalawang groups to be isomorphic. No? Okay. How can we say that they are isomorphic? Sabi, if you can establish a function, I denote the function by phi. Now the function phi goes from G to H, where anong klaseng function ito? Syempre hindi lang naman basta-basta function. Number one, phi must be bijective. When you say bijective, 1-to-1 and onto. Alam niyo, ang ibig sabihin lang naman that there is a bijection from G to H. Sa madaling salita, pag naririnig niyo ito sa math, it only means to say, this is a mathematician's way of saying that the number of elements in G must be the same as the number of elements in H. Or kung infinite man sila, the cardinality of G must equal the cardinality of H. Kasi if the cardinalities are not the same, then this bijection cannot be established. So did you understand number one? Again, kapag nakakakita kayo that there is a function, there is a bijection from one set to the other, this is just our way to say that two sets have the same number of elements in mathematics. Okay? Number two. Yan. Number two, the function must preserve the binary operation. Isa lang ang operation, so I preserves. Isa lang ang operation, kaya dapat walang S yan. Okay? The function phi must preserve the operation in what sense? Now, when you look at this table, once again, no, tignan nyo, no? So here, the isomorphism that we're really interested in is this mapping. No? Yung mapping na ito. Yung pangalawa ang nagbibigay buhay sa pagiging isomorphism. No? In the sense of the following. Halimbawa, if I multiply R times A on the group G, no, in G, R times A is L, correct? Tama? On the other hand, correspondingly, in the group C of 4, R corresponds to 1 and A corresponds to 2. But then the operation in Z sub 4 is addition modulo. Ay, tama ba ako? Yeah, no? But then the operation in Z sub 4 is addition modulo 4, so 1 plus 2 is 3. Dapat daw kung si R nagko-correspond sa 1, si A nagko-correspond sa 2, dapat yung product na L nagko-correspond dun sa sum na 3. Did you understand? Yung sabihin natin ng addition preserving. Yung sinasabi natin when we write phi of R circle A must equal phi of A plus phi of R plus phi of A. Ito yung L, no? Ito yung phi of R is 1 and phi of A must be 2. So, dapat yung phi of L must equal 1 plus 2. In this case, that's 3. Did you understand? So, as you can see dito, yung operations ay of course magkaiba. They're totally different. Yun yung mensahe ng condition number 2. Kailangan yung image ng product A times B or A star B, as A times B is happening in G, must be the product of the images phi of A and phi of B. Kung gusto niyo matandaan yung equation na ito without memorizing symbols, you can just say that the image of the product must be the product of the images. Of course, by the word product, I mean the way you combine them in the respective groups. Dito, yung ginagamit nating operation ay star kasi si A and B are elements of G. But this time, I'm using the operation diamond now because phi of A, if A and B are in G, yung phi of A tsaka phi of B, they are now elements of H. Kaya ang gagamitin mo ng operation ay yung diamond. Okay? Such a function phi, if we can construct it, is what we call a group isomorphism. So basically, there are many bijections from G to H sa totoong buhay. Halimbawa, dito sa nakarang example ko, maraming ibang bijections. Pero hindi lahat ng bijections will preserve the operations. Kumbaga, hindi ka pwede randomly mag-assign ba? Si I gawin mong 3, si R gawin mong 2, si A gawin mong 1, si L gawin mong 0. That's a bijection, but I mean, it will not be an isomorphism. An isomorphism is more than just a bijection because it has this operation preserving property. Kailangan na satisfy ito. Did you understand this definition now? Okay. Again, to recall, ang ibig sabihin natin ng one-to-one, para lang maintindihan nyo, kailangan kapag ang phi of A equals sa phi of B, dapat nagko-follow na si A ay equal to B. Pag sinabi naman natin onto, yung range ng function mo is all of H. Diba? Remember, the range can be smaller than H. Hindi lahat kasi ng H ay nagagamit necessarily. Pero kapag gusto mong maging onto, kailangan lahat ng elements ng H nagagamit as images. Meaning to say, for every element little h of capital H, an element G must come from capital G whose image is exactly H. Sabi, nagagamit lahat ng element ng H as an image of something coming from G. Ayan. As in the previous example, an isomorphism that you can establish is, well, you can map I to 0, map R to 1, map A to 2, and map L to 3. You can check one by one that this is operation preserving. It's obviously bijective, but to check that it preserves the operation is quite harder to check this time because there are a lot of cases. Ilang pairs ang i-consider mo? 16. Kasi meron kang 16 elements in your table. No? Pero hindi nyo na kailangan i-check kasi by just looking at the colors, it really, indeed, is an operation preserving map. No? Tingnan nyo na lang yung kulay. No? Kaya kung nga kinulayan, so you can see that this is operation preserving. Okay? Now, let us take another example. Okay. Here, there are two groups that I am talking about. First group is the set of real numbers under addition. So this is the additive group of real numbers. The other one is the set of positive real numbers. Pag sinabing R plus, again, alam mo na ito yung mga real numbers that are all positive, Now you can check that this is a group under multiplication. Paano nangyari? First of all, close to yan, no? Under multiplication. Pag minultiply mo ang dalawang positive, positive, di ba? Okay. Associative naman ang multiplication, walang duda doon. Ang identity element in this case ay, anong identity element under multiplication? 1. Right. At so, kung si A ay positive, meron ba siyang multiplicative inverse? Yes, no? Yung 1 over A kasi palagi yung positive din. Or in other words, it's in R plus. So, lagi nag-exist yung inverses ng mga positive. So, it's a group under multiplication. Okay? Now, here in this example, yung positive reals under multiplication is basically what? Isomorphic to the set of real numbers under addition. Kumbaga, as groups, they are not really different from one another. You know why? Kasi we can establish an isomorphism. Now, a function that I can think of is this function, no? Kasi, ang bawa, ito binigay ko kasi, paano kung kayo yung mag-iisip, no? Paano nyo maiisip that this will work? Now, you wanted to have a function whose domain is R, whose range is all of R plus. Gusto mo ng function na ipapadala yung buong real number line sa mga positive real numbers. 1 to 1 and on to. Pangalawa, you wanted it to be operation preserving. No? Ang naisip kong function that will actually work is the natural exponential function. Yung e to the x nyo sa calculus. So as you can see, kapag si x ay real number naman talaga, yung e to the x talaga kasi ay positive. Hindi yan nag-zero, hindi yan nag-negative, right? No? So, yan yung naisip kong function. You can check that this map is 1 to 1. Paano ko naisip na 1 to 1 yan? Kasi kapag kumuha ka ng dalawang real numbers na x and y, and you assume that epsilon of x is equal to epsilon of y, ano mangyayari? Then mangyayari e to the x is equal to e to the y. Correct? But then, this equation will mean e to the x times e to the minus y is 1. Diba? So that will mean e to the x minus y is 1. Eh, ang exponential nagiging 1 only when the exponent is 0, diba? So that means x minus y is 0, or that means x is equal to y. So really, epsilon is a 1-to-1 function. Yung natural exponential function. Kapag rinaf nyo nga yan, di ba? Sa calculus, ganito yung itsura niyan. Parang ganyan. Diba, yung domain niya is all of R, tas ang range niya is the positive reals. Right? 1-to-1 siya. Sa calculus, paano nyo nalalaman if a function is 1-to-1? By looking at the graph, how will you know in calculus if the function is a 1-to-1 function?
Vertical line.
Horizontal line test. If you draw horizontal lines, you will find that it will intersect your graph in at most 1 point. Epsilon is onto, given ito kasi from your calculus class, you know that the range of the natural exponential function is the interval from 0 to infinity or r plus. There's really no need to check that. No? Okay, why is it operation preserving? Ang ibig sabihin ko nung phrase na ito, pag sinasabi ni sir na epsilon preserves operation, ang ibig sabihin ko na ito, pag kumuha ka ng dalawang elements ng domain, in this case R, then anong operation ng R? Diba sum, kaya x plus y, i-apply mo yung epsilon, and if you apply epsilon, you get e raised to x plus y. That's the definition of epsilon. You know, in algebra, this is equivalent, or this is equal to e to the x times e to the y. laws of exponents in the natural world, no? The real number world. Yung e to the x, that's epsilon of x times epsilon of y. Ayan yun. Yung addition, ito yung addition ni r. Yung multiplication dito, yun yung multiplication ng r plus. So, indeed, the natural exponential function gives you what? Gives you a natural isomorphism from r comma plus to r plus comma dot, no? Yung dalawang groups na ito. Parang you can think of them as two parallel universes, no? Parang magkaiba yung itsura nila, pero kung ano yung nangyayari dito, nangyayari din doon. Pag nag-add ka ng dalawang elements dito, yung corresponding elements nila dito, nagmo-multiply lang. Kasi kumbaga, iba man yung itsura ng mga bagay na nandito, imaginein mo, mga tao nandito, dito mga alien, no? Iba man ang itsura ng mga nandito, but basically they correspond to one another. Parang bawat isa dito may katapat doon. Okay? Do we have another example? Yes, I think. Yeah. Okay. Did you remember this example? I asked you to do this before, but somehow bigla na lang na ano to, napunta sa ilalim. Hindi natin to na pag-usapang maigi, but let me just recall this one. So I take x to be the set consisting of 0 and 1 only. Okay? Now, you know that P of x is the power set of x. It contains all the possible subsets of x. So here, in this list, there are 4 subsets of x, namely the empty set, the 2 singletons, and all of x. Okay? Now, on the power set of x, define yung operation na ito, yung circle plus. Yung operation na circle plus na yan, I define it as the difference union minus intersection. Tinatanggal natin yung intersection from the union of two sets. So for example, how did I come up with this table? Ginawa natin ito before. Halimbawa, how did I come up with this circle plus this one? Ano ba? Ibig sabihin ng paano nangyari yung sagot na yun? No? Ibig sabihin nito, kukunin mo yung union, tapos tatanggalin mo yung intersection. Okay? Okay. Ang union nila, because x is the universe, ang union is x. Ang intersection ng singleton 1 and the universe is the singleton 1. So from the universe x, remove the singleton 1, what's left is the singleton 0. Okay? So in the table, yung 1 circle plus x is 0. And then here, I have just completed the table for you. Okay? First of all, let us kind of explain why this one is a group. Sige nga, bakit nga ito group? Sino yung pumapapil na identity element? Anybody? Sino yung identity natin dito? Okay. The empty set plays the role of the identity. Correct. Now, if I'm going to list down all the elements, can you name the inverse? Halimbawa, si empty set, sinong inverse niya? Sarili niya. Di ba? In fact, as you can see here, because the diagonal are all empty sets, in other words, are all identities, ibig sabihin, every element is a self-inverse element. Ibig sabihin, ang inverse ng bawat isa ay yung sarili nila. Okay, that's an indication. Okay. As you can see, this example of a group came out of nowhere. Nabigla na lang ako nag-define ng ganyan, so bigla ako na lang naisip na i-define yan. But you see, it's actually isomorphic to the Klein for group V4. Now, ano nga yung Klein for group V4? Na-mention ko ito before, but just so you know, ito ulit yung pag sinasabi ni sir na client for group, this is what I mean. Okay? So pag sinasabi nating client for group, I am denoting it by V4. I know that before, ang notation na ginamit ko yata ay epsilon, alpha, beta, gamma, if I'm not mistaken. But from now on, I will denote them by EABC for short. Now, anong nire-represent ng EABC na yan? If you can remember. Ang EABC na yan, ito yung symmetries ng rectangle. No? You have a rectangle in picture or in your mind, and make sure that this rectangle is not a square. Okay? Now, ano yung E? Yung E is the identity. Walang ginagawa yung E. E does not do anything to the rectangle. Sino si A? A is a mirror reflection about the x-axis. B is a mirror reflection about the y-axis. And C is a 180-degree rotation. Okay, 180-degree rotation of the rectangle. Yan yung apat na yan. Now, anong natutunan natin sa group na ito? Ito yung group table niyan. E, A, B, C. Because E nga yung identity, dapat E, A, B, C to, tapos ito rin A, B, C. So, as you can see, si A is a mirror reflection. If I do A times A, what do I get? What do I get if I get A times A? E. Kasi if I reflect about the x-axis and I reflect once again, I get the same element. Diba? That's E. In fact, si B ay order 2 din. Pag sinabing order 2, babalik siya ulit sa identity after applying it twice. Diba? In fact, C, is of order 2. If you rotate 180 degrees and rotate 180 degrees again, you will go back to the identity. That's the same effect as the identity. So here you get the following. Now, because we're talking about a group, this is a group, remember, by the Sudoku property, makakomplete nyo na yung table. You don't really have to multiply everything because we know that this is a group. Now, we know that the Sudoku property holds. Ano yung Sudoku property? That's another name for the cancellation laws. Pero ang ibig sabihin nun, in a finite group, in the Cayley table, no two elements can be repeated in a row or in any column. So, halimbawa, ang choices mo na lang sa second row ay B at C. Siyempre, hindi na pa pwede yung BC. Dapat C, B na yan. Diba? Tapos dito A, tapos dapat ito C, tapos ito dapat B, at ito ay dapat A. So, you don't need to really worry computing. Diba? Now, let me copy this table and compare it side by side with the previous example. Let me erase this one, ha? Alam na kasi natin na siya ay group. Ito rin, burahin ko na. Ito yung client for group. So, pag sinabi ni sir yung client for, this is the table that should be in your mind. E is on the diagonal, okay? E being the identity. Okay, that's the client for group. Now, can you give me the isomorphism? Kasi to show that they are isomorphic, you just need to exhibit an isomorphism. So, can you give me an isomorphism from P of X to V4? So, sige nga, sinong i-assign ko sa empty, sa 0, sa 1 at sa X para maging magkamukha yung dalawang tables na yan? Of course, that's just E, A, B, C. And this gives you the complete, this gives you an isomorphism. Did you see why? So pag sinabing show that this group is isomorphic too, you just need to exhibit an isomorphism. Now, in this case, because the group is finite, I don't really need to check all the multiplications. So, pwedeng gumamit ako ng coloring technique. Now, halimbawa, Kulayan mong dilaw to. Tsaka yung E. Dilaw, no? Kulayan natin to kunwari ng pula. O, di ba? So, saan pa may pula? Saan pa may dilaw? Sorry, ito pala yung mga pula at dilaw. So, dito, pula is ito. Okay, tapos dilaw, ito. Okay. Ano pang kulay? Halimbawa, ito kulayan natin ng green, yung 1 at B. Oh, ano nangyari? Sorry. Saan ako napunta? Ayan. Okay, yung 1 at B, kulayan natin ng green. Diba? Tapos yung natitira, kulayan natin ng blue. Yung X at C. So as you can see, by just ignoring the elements, the names of the elements, you just think of the colors, you see that you find that they are the same tables essentially. Did you understand? Did you understand me? Okay. So that's how you know the isomorphism. Now, group isomorphisms in general are basically functions. And as functions, they tend to follow certain properties, not because they are functions, but because they are isomorphisms, no? Halimbawa, for example, so I have listed here 6 properties of group isomorphisms that you might be interested in, no? For example, number 1, what does it say? If F is a group isomorphism from G to H, dapat daw yung identity ni G ang nagko-correspond sa identity ni H. Or dapat a group isomorphism must always take an identity to another identity element. Hindi pa pwedeng yung identity element ma-map mo sa ibang element other than the identity in the other group. Now, that is not possible. Sige, gawin natin to one by one. Let me explain this to you. Halimbawa, sige. So, let's assume that F from G to H is a group isomorphism. Okay? So, for number 1, we will prove that the identity of G gets mapped to the identity in H. Kung titignan niyo yung mga examples ko ng mga isomorphism, ang identities are always matched with one another. Hindi pa pwedeng hindi. Bakit ito mangyayari palagi? Ito yung reason. Tingnan nyo ha. The proof is the following. If I multiply the identity of H and f of EG, now remember, this is an element in H and this is an element in H because may F siya. Kapag may F ka, nandoon ka na sa H, di ba? If I multiply the identity of H here, no, anong mangyayari dyan? Ano mangyayari dito? Di ba f of EG lang din ito? Kasi EEH is the identity in H, correct? Tama ba si sir? Agree, okay. Now, on the other hand, yung EG sa loob, pag minultiply ko siya sa EG pa rin yun. The identity ni G times identity ni G is the same as the identity of G. Na ito na. Because F is operation preserving, yung F of the product must be the product of the F's. Ano yung sabihin nun? It is equal to F of EG times F of EG. Okay? Tama ba? Yun yung sabihin natin. Yun nga lang ito. Let me just write here as a comment. Itong unang dot na yun, operation in G. Pero itong pangalawang dot na to, this is an operation in H. Wala lang ako naka-specify na symbols kasi kaya ginagamit ko dot. Okay? Alright. So, as you can see, anong equal? Ito daw ay equal doon. So, by right cancellation law, sa H is a group, so nag-hold din yung right cancellation law. Pwede kong cancelin itong dalawa. Diba? Pag kinancel ko yan, anong mangyayari? EH is F of EG, which is number 1. Yan yung gusto nating patunayan. Ay, sorry. Yan yung gusto nating patunayan sa number 1. And we are done here. Nasundan nyo ba yon? Nasundan nyo ba yung proof no number 1? Okay. Number 2. Number 2, ha? Okay, tingnan natin. F of A inverse is equal to F of A inverse for all A in G. Ibig sabihin ng number 2, F does not only preserve operations, F also preserves identities, F also preserves inverses. What do you mean by this? Kung babasahin mo to in English, the image of the inverse of A must be the inverse of, mali. The image of the inverse of A must be the inverse of the image of A. Magkaiba yung left at right niyan eh, di ba? Yung una, kukunin mo muna yung inverse ni A bago mo i-apply si F. Yung pangalawa, apply mo muna si F bago mo kunin yung inverse. But they will always lead to the same thing. Why is that so? Kasi pag minultiply mo yung F sa F of A sa F of A inverse, these are elements in H, kaya multiplication and I kay H. Because F is operation preserving, that's the same as F of A times A inverse. Now, A times A inverse is equal to, saan equal yung A times A inverse? Okay, ini yan, ni G or ni H? Ni G or ni H? Nasaan ba si A? Nasaan ba si A? Si A ay nasa G. So, meaning to say, yung A times A inverse will give you the identity of G. Now, what is F of EG? It's EH by number 1. Okay? So, as you can see, if I multiply these two things together, it results the identity of H. Similarly, if you do the other direction, it will also give you EH. So, magkaano-ano itong dalawa? If when they are multiplied, it gives you the identity. So, magkaano-ano sila? Dapat yung isa yung inverse ng isa. Kaya dapat, yung F of A inverse must be the inverse of F of A. Sige, to give you an example, why is this true? Ganito. Balikan natin yung, for example, balikan natin yung epsilon, yung mula sa R plus to R plus times. Yan, ganyan. Yung x natin, minamap natin sa e to the x. Okay? Alright. So if I take an element of R, what element do you want? Halimbawa si 2. 2 na lang, no? Let's say x is 2. Okay? So what is the inverse of 2 under addition? Ano yung inverse ng 2 under addition? Negative 2, okay. So tignan nyo ito. I-apply ko ngayon yung epsilon sa 2, it will give me e squared, correct? Yung katangian ng epsilon. If I now apply epsilon on the inverse of 2, I get e to the minus 2. Right? As you can see, e to the minus 2 is the reciprocal of e squared. So, yung inverse under multiplication, kung e squared ay 1 over e squared. Yun yung ibig sabihin natin when I say epsilon of the inverse of 2. In this case, ang inverse nga lang kasi negative 2. No? So, tatandaan nyo, although in my theorems, notations being used are multiplicative, pero babaguhin nyo siya just in case that the operation is addition or depende kung anong group yung pinag-uusapan. Naintindihan nyo? Or mas maganda yatang isulat ng ganito. Epsilon of the inverse of 2 is equal to the inverse of epsilon of 2 under multiplication. Mas maganda siya isulat in this manner. Di ba? Kasi parang yun naman talaga ang meaning nito. Although in the theorem, the notations I'm using is multiplicative. Sinabi ko naman yun from previous lesson, di ba? By default, pag walang operation na binibigay in a group, no, let's say in a discussion of a theorem, we will by default use the multiplicative notation, but that doesn't mean that the operation is always multiplication. Okay? Naintindihan niyo ba ako doon? Maraming mga estudyante, hirap na hirap unawain yan sa umpisa. No? Multiplication ang tawag, pero minsan addition siya. No? Depende sa context. Okay, so that's number 2. How about number 3? Isomorphisms also preserve powers. F of the n power of a, when you say n power of a, repeated multiplication of a with itself n times, di ba? Parang ganun yan. Pero kung negative si n, may a to the minus something ka dyan. Alam niyo naman yung meaning nun. Repeated a inverse lang naman yun. Tapos, ang f of a to the n daw equal lang sa f of a raised to the power of n. But of course, pag addition ng operation, repeated addition ang meaning niyan. Okay? Depende yan sa context ulit. So why is that true? Kasi pag meron kang f a to the n, no, what does this mean? Sige, tingnan natin ha. Sige, 3. F of a to the n, what does this mean? Okay. If n is 0, what does that mean? F of a to the 0. F of the identity ang meaning niyan, di ba? Identity in G. And that's EH. Nagkataon yan yung F of A raised to 0. Di ba? Tama? Di ba? An element raised to 0 in a group, it means the identity. Okay. If n is positive, ang f of a to the n will mean f of a, n times. But because f is multiplication preserving, magiging f of a times f of a, n minus 1. Diba? Tapos you keep applying the operation preserving property hanggang maubos, is unti-untiin mo. Eventually, kakalat yung f of a, maging f of a lahat yan. How many f of a's are here? There are n. Kaya that's f of a raised to n. Okay? If n is negative, paano pag si n ay negative? Sir, ano yung sabihin ng f of a is, if n is negative? What do you mean by this? So if n is negative, write n as minus m. Yung m na to, positive. Diba? Kung negative man si n, yung negative niya ay positive. Okay? So, sabihin, ito ngayon ay f of a to the what? Minus m. Okay, ba't ko sinulat ng ganyan? Kasi ang f of a, ang a to the minus m, do you remember it's the inverse of a to the m? By applying number 2, pag may inverse dyan sa loob, pwede mong ilabas. Because m is positive, yung pangalawang case ay nag-hold, magiging f of a to the m to, tas inverse. But that's just the same as f of a to the minus m by law of exponents. Kaya ito ay f of a to the n pa rin. Kaya in any case, ang f of a to the n is equal to f of a to the power of n. Did you understand? Kaya yung number 3 na ito ay gumagana. And because of number 3, if f is an isomorphism, kung ano man yung order ng A sa G, remember, pag sinabi order, it is the smallest positive n so that A to the n is the identity. Because of number 3, kung ano man yung order ng A, yun din yung order ng f of A. Kasi nga, ang f of A to the n is equal to the n power of f of A. Kaya pag naging identity ito, magiging identity ito. Did you understand? Okay, number 5. If A and B commute in G, then so do f of A and f of B as elements of H. Why is that so? If AB is equal to BA in G as elements in G, then bakit nagko-commute yung f of H at f of B in H? Kasi ang f of A times f of B in H, remember, is the same as f of AB. Kasi nga, operation preserving si F. And because AB is BA, pareho sa BA, so pareho sa FB, f of A as elements in H. Ganun lang kadali yung number 5. And it must follow from number 5 that whenever G is abelian, dapat yung H din ay abelian. So, sabihin, if G and H are isomorphic groups, hindi mo pwedeng abelian yung isa tapos yung isa hindi abelian. That's weird, no? Kung abelian ay kung isomorphic ang dalawang groups, pag abelian yung isa, dapat abelian din yung isa. Ito yung sinasabi natin. Proof, nagawa na natin isa-isa, but basically, yeah. Now, because of the properties that we have established, we can now say the following. If one of these statements hold, we can say that G and H are not isomorphic. Paanong hindi nagiging isomorphic ang dalawang groups na? Okay, number 1. First of all, if G and H have different cardinalities, napaka-obvious na ito. Kasi kapag halimbawa si G may 3 laman, si H may 10, wala kang bijections na magagawa from G to H in the first place. So, no isomorphism can ever be constructed. Nagets nyo yun? Nagets nyo? Okay. Number 2. If G is abelian while H is not. Kasi nga sabi nung theorem kanina, kung si F ay isomorphism from G to H, dapat kung si G ay abelian, dapat si H din ay abelian. Kaya kapag nakakita ka ng dalawang groups, yung isa abelian, isa hindi, anong conclusion? Aha, hindi pwedeng maging isomorphic yung dalawang yun. Okay? Number 3. G has K elements of order N, while K has L elements of order N, where K is different from L. Wala, ano yung sabihin na ito, sir? Naalala niyo yung property number, what's that? This property, yung, yeah. If A has an element of order N, dapat yung image niya, another element of order N. Because F is a bijection, ibig sabihin, kung may 10 elements of order 10 sa G, dapat meron ding 10 elements of order N sa H. Kaya kapag ito ay may 3 elements of order A of 10 lang, Pero to may 5 of order 10, bawal yun. No, hindi pa pwedeng ganon. Did you understand? Hindi pa pwedeng magkaiba yung bilang ng number of elements of a given order. Halimbawa, napansin mo dito may 3 elements of order 2. Dito may 5 elements of order 2. Ay, hindi sila pwede maging isomorphic. Dapat kasi parehas yung bilang nung dalawang yon. Okay? Okay. Binibigyan ko kayo ng hints paano malaman or ma-detect na mabilis kung ang dalawang groups ay hindi isomorphic. Sige nga. Let's explain why each of the following pairs are not isomorphic. Naku. Okay, alam natin yung Z sub 6. Yung Z sub 6, ito yung 0, 1, 2, 3, 4, 5. Diba? Addition modulo 6. Correct? Yung S3, ano nga to? 0, 1, 2, 5. Yung S3, ito yung 6 na na bijections. Yung ID, row 1, row 2, mu1, mu2, mu3. Naalala nyo to? Ito yung 6 na bijections on the set 1, 2, 3. Ang operation dito ay composition of function. Okay? Do you remember this? Sige, hanapin ko yung aking definition yan. Saan ba natin na-discuss to? Wait a minute, hanapin ko ha. I think dito sa invertible functions ko uno na-introduce yung 6 na yun. O, yun dun ba? Sandali. Or hindi. No, hindi dito. So, ano na. Nahanap ko yung mga nakaraang slide. Ayun. Ito oh. Okay, naalala niyo S sub 3? Anong pinanggalingan nila? Ang pinanggalingan nila ay yung 6 na functions na ito. Ayan. If you can remember, yan yung meaning ng S sub 3. Naalala nyo na? Yan. Yan yung 6 na bijections. Paano nyo ba matatandaan yung mga ito? Yung ID, row 1 at row 2, ito yung rotations ng triangle. No? Yung mu1, mu2, mu3, ito yung mirror reflections. Ang hint dito, yung mu1, finifix si 1, pinagpapalit si 2 and 3. Si mu2, finifix si 2, papalit si 1 at si 3. Si mu3, fix si 3, papalit yung 1 and 2. Itong row 1, row 2, umiikot, no? Si 1 pupunta sa 2, si 1 pupunta sa 2, si 2 pupunta sa 3, si 3 pupunta sa 1. Okay? Si row 2 naman baligtad yung ikot niya. Si 1 pupunta sa 3, si 3 pupunta sa 2, si 2 pupunta sa 1. Ito syempre walang ginagawa. Okay? So ayan. Yan yung meaning ng 6 na yan, and yung group table niyan is as follows. Sige, kakopy ko tong group table na to ha. Ikakopy ko yung group table. Paano ba to? Tapos, ipipaste ko dito sa bagong ano natin. Paano ba to? Ayan. Sige nga. Bakit ang Z sub 6 hindi isomorphic sa S sub 3? Can you give me a reason for this? What justification would suffice? Bakit hindi parehas? Ay, anong ginagawa ko? Who would like to answer? Anong justification? Bakit hindi yan isomorphic sa Z sub 6? Ito yung pinakamadali dyan sa tatlo. Bakit hindi sila isomorphic? I don't
Not
even need to
commutative.
construct the table ng Z sub 6. Bakit hindi sila isomorphic?
Not commutative po yung S3.
Okay, very good, very good, very good. One reason that you can give that suffices to prove that they are not isomorphic is the fact that Z sub 6 is abelian while S sub 3 is not. No? Excuse me. Kita nyo naman from the table itself, this is non-abelian, this is abelian. So they cannot be isomorphic even though they have the same cardinality. Ito yung sinasabi ko. Hindi rin naman porket magkasing dami ng elements yung dalawang groups, hindi ibig sabihin nun isomorphic na sila. They can have the same number of elements even when they are not isomorphic. In fact, ito yung magpapahirap sa group theory. No? Pero pwede pala yun, no? Magkasing dami sila pero hindi sila isomorphic. Yes, kaya nga ang tanong natin sa dulo ng semester, no? Kailangan, pag pinalista sa inyo ni Sir, ano-ano yung iba't ibang groups of order 6? Dapat kaya niyong i-identify kung ano lahat ng mga groups of order 6 later. For now, nagsisimula pa lang tayo. We are trying to explore, no? So for now, meron tayong nakitang dalawang examples of groups of order 6. Si S sub 3 at si Z sub 6, no? Correct? Ang tanong, meron pa bang ibang groups of order 6 na hindi isomorphic sa Z6 or sa S3? Yun yung ating aalamin. Later on, mapoprove natin wala na. There are only two groups of order 6 up to isomorphism. Galing, no? Paano kaya naging dalawa lang? Hindi man lang naging tatlo, naging apat. Na ba't kaya dalawa lang? We will see that later. Magkakaroon tayo ng mga results in the future. Okay. Number 2. How about Z sub 4 versus V sub 4? Ano nga yung Z sub 4? Ito yung IRAL din, or kung yung mamarapatin, 0, 1, 2, 3, isusulat kong ganito. Okay. Next, can you tell me why they are not isomorphic, ha? Ito, sige, EABCN. Magkasing dami naman sila ng laman, no? Magkasing dami sila ng laman. Pangalawa, parehas silang commutative. Sir, bakit hindi sila isomorphic? Sige nga, bigyan niyo ako ng reason. Bakit hindi sila isomorphic?
Not same order po.
What do you mean by not same order?
For example po sa, wait lang po.
Okay.
Kuwari po sa 1, ang order niya po is sa 3, di ba? Order 3 po yung 1. Then yung A po, ang order niya po ay CE, which is the inverse. Ay, yung self-inverse po siya. So 2, order 2 po yung
Ganito ha, baka kasi nagkakaroon kayo ng false impression na laging ang correspondence laging pag ganito. Hindi pa laging ganyan yung mapping na i-consider natin. Kasi the truth is, pwede mo i-map yung yung 0 laging sa identity. Pero for example, yung 1, I can map it to C, si 2 kay B, si 3 kay A. That's also possible. Because there can be more than one isomorphisms between two isomorphic groups. Baka kasi nagkakaroon kayo ng impression na laging ang mapping dapat tapat-tapat talaga, as in tapat-tapat. The truth is you can rearrange the elements in a table and give you the same table. So, hindi pa laging si 1 si A, si 2 si B, si 3 si C, no? Hindi laging ganun yun. Baka nagkakaroon kayo ng expectation na ganun. Pero ito na nga, nabanggit mo na rin yung orders. Yung binagsasalta si Aaron ba yun?
Yes po.
Okay. Ang pinakamadali, huwag mo nang pagtapat-tapatin kasi nga they are not isomorphic. Don't try to make a one-to-one correspondence, but instead, just look at the order of elements. Halimbawa, in Z sub 4 and in V sub 4, anong order ng 0? Identity, order 1 palagi. Ang 1, order 3 kasi kailangan mo ng order 4 pala. Kasi kailangan mo ng 4 na 1 para maka-0? Anong order ng 2?
Order 2.
Order 2. Kasi kailangan mo ng dalawang 2 para maka-0. Anong order ng 3? How many 3s do I need to get 0 back? Very good. 4 ang minimum na kailangan ko. So, ang orders ng mga elements sa C sub 4, 1, 4, 2, 4. Okay. How about inclined for group? Anong order ng mga elements maliban sa identity? Nakita niyo yung main feature nito, yung main diagonal. Identity lahat. Pero dito hindi. Diba? It is because lahat ng elements maliban sa identity ay order 2. Ang configuration ay magkaiba. Halimbawa, you can say or you can argue that there are exactly 2 elements of order 4 in C sub 4, but there is no element of order 4 in V4 or inclined 4. Or you can say that there is exactly one element of order 2 in Z sub 4, while there are exactly 3 elements of order 2 in inclined 4 group. So therefore, they are not isomorphic. Di ba binanggit ko yan? Did you understand? So, nilista ko dito yung mga iba't ibang possible reasons kung paano nyo masasabing hindi isomorphic ang dalawang groups. Naiintindihan nyo, si sir? Oh. Okay. Kasi dapat, kung gagawa ka, ang reason kaya hindi na sila isomorphic, pag gagawa ka kasi ng isomorphism, dapat ang order 4, mamamap mo sa order 4. Ang order 2, mamamap mo dapat sa order 2. So, ibig sabihin, hindi ka pwedeng makagawa ng isomorphism kasi wala kang pwedeng pagdalhan ng 1. Kasi wala kang ibang choice doon sa V4. Wala namang element of order 4 doon eh. Remember, kung order 4 ang element, yung image niya dapat order 4 din under the isomorphism. Yun yung idea. Okay? Number 3, ito yung pinakamahirap sa lahat. Why is the set of real numbers under addition not isomorphic to the set of integers under addition as a group? Sinong would like to answer, Aaron?
Magkaiba po sila ng cardinalities po.
Yes.
Uncountable po yung real, yung Z po countable.
Yes. Buti alam nyo naman yung uncountable, countable. Kasi I thought that hindi nyo napag-aralan nyo ba yung uncountable, countable sa sa FCM?
Hindi po. Chinika lang po ni ma'am.
Chinika lang. Oh my gosh. So si R tsaka si Z parehas mga infinite sets kasi ito, but they are two different types of infinities. Okay? For your information, si Z is a countable infinite set, countably infinite set. Sabihin ng countably infinite, cardinality niya denoted by aleph null, no? Sabihin ng countable infinity, kasing dami niya yung mga counting numbers. Anong masasabing kasing dami? Pares infinite yan, sir. Pero pwede mo ilista kasi yung mga integers in this manner at certain ka na hindi mauubusan ng kapartner. And so on. Countable yan. Unlike si R is not countable infinite. Hindi siya countable. Mas malaki yung cardinality niya sa cardinality ng Z. There are a number of reasons and I wish we have time to talk about this, but unfortunately we don't have. Siguro saan ba dinidiscuss to? Diba ni-review namin to nung nagturo ko ng tignan ko. May klase akong tinuro ko yan eh. Ni-review ko yan. Nagturo ko ng advanced calculus. Wait lang. Hanapin ko sa slide nun ha. Ito yung advanced calculus sa slide namin. There are many types of infinities. Ano ba to? Yeah. Ang proof na yung R ay hindi countable starts with the proof that this interval from 0 to 1 is not countable. Kasi ang proof nito ay by contradiction. Kunwari countable siya, so pwede mong ilista yung mga elements nito in one-to-one correspondence with the positive integers. Like, so kunwari nailista mo. Okay? Ang gagawin mo dyan yung diagonalization argument. Titignan mo yung mga nasa diagonal. Okay? Kung ito ay, ayan, kung ito ay 9, gagawa ako ng, ganito, gagawa ako ng bagong decimal, E pala, ang ginamit ko dyan. Gagawa ako ng bagong decimal, where, yung first digit na to ay 0, kung ito ay 9. Kung hindi ito 9, gagawin ko lang tong 9. Basta ganun yung idea niya. Kasi itong pangalawang digit, depende siya dun sa second diagonal element. Kung ito ay 9, gagawin ko tong 0. Kung hindi ito 9, gagawin ko siyang 9. So yung decimal na to parang 09, 09, 99, blah, 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 blah. So as you can see, this decimal cannot be equal to any one of this. Kasi hindi to equal dito kasi hindi sila parehas ng first decimal places. Hindi to equal dito kasi hindi sila parehas ng second decimal places. At hindi to equal dun sa kahit na sino dito sa listahan. So, therefore, hindi mo pwedeng sabihin na ito ay countable na mailalista mo kasi lagi ka makakapag-exhibit ng isang element na wala dun sa listahan. Ngayon, bakit si R ay uncountable? Kasi makakagawa ka ng bijection for between the interval 0, 1 and the real number line. Ito example ko, yung function na yun. Yung tangent of pi times x minus 1/2. Yung graph niyan ganito. Okay? Ito yung 0 to 1. Kasi ito yung buong real number line. Yung range niya yung buong real number line. So meaning to say, magkasing dami ng laman kasi you can place them into a one-to-one correspondence. Kasi when mathematicians say that two sets have the same number of elements, mathematicians don't count. We hate counting. No? Ang mga mathematicians, they hate counting. So what we do if we want to prove that they have the same number of elements, we establish a bijection from one set to another. If you can establish a bijection, then that's it. Magkasing dami sila na elements. And this is the bijection. Kaya kung ito ay uncountable, dapat si R din ay uncountable. Kaya yung pagiging infinite ni R ay iba sa pagiging infinite ng Z. Okay? I wish somehow nabigyan ko kayo ng light about this. Ano yung cardinality ngayon ng R? Ang tanong nyo sa akin ngayon, ano yung cardinality ng R kung hindi aleph null? Yung aleph null, siya yung pinakamaliit na infinity. Okay? Siya yung infinity ng counting numbers. 1, 2, 3, 4, 5. Diba kung nagbabasa nga kayo ng book ni John Green, ano ba yun? The Fault in Our Stars, may nabanggit doon that some infinities are bigger than the others. That's mathematically correct. Kasi si John Green, hindi lang siya basta writer. He's actually a math major. Kung hindi nyo na tatanong, you can research about him. Kaya maraming mga math references doon sa mga librong sinusulat niya kasi na-realize ko rin, minsan binabasa ko siya, nararamdaman ko meron siyang math vibes. Tapos sinerch ko kung anong natapos niya. May math major din pala si John Green. Kung kilala niyo si John Green, kilala si John Green? Isang mulat ng The Fault in Our Stars. Naging movie pa nga yata yun.
Opo, sir.
Oo. Sabi niya, dun sa The Fault in Our Stars, there are infinities. Some infinities are bigger than the others because that's true. Kung may aleph 1, yung aleph 1 ay aleph 0 pala, siya yung infinity na kasing dami ng mga counting numbers, okay? Yan yung aleph null. Ang basa dyan, aleph null. Yung aleph is the first Hebrew letter. Kumbaga sa Arabic, alif. Sa Hebrew, aleph. Parang yun yung A nila. Parang nagsusulat sila pabalik, di ba? Yung mga Arabo, tsaka yung mga Hebrew. Yan yung first letter nila. Anyway, ano yung Aleph 1? Yung Aleph 1, kukunin mo yung power set ng mga positive integers. Kunin niyo yung power set. Lahat ng mga subset nito, yung cardinality nun, laging mas malaki sa cardinality ng n. At ito yung definition natin ng Aleph 1. Ganyan. Ganyan yon. Sino naman si Aleph 2? Kunin niyo yung power set ni n. Sabi kasi ni Cantor, laging mas malaki yung cardinality ng power set sa kahit sa cardinality ng given set. Imaginein mo, no? Kukunin mo yung sets ng mga subsets ng n, tapos kukunin mo ulit yung set ng mga subsets ng mga set of subsets na yon. Oh my gosh. Kung i-imagine niyo, nakakabaliw, no? Yun yung Aleph 2. And so, kung ilang beses ka kumuha ng power sets, palaki ng palaki yung mga infinities na yan. How many infinities are there? There are infinitely many. Nakakabalo kung iisipin mo, no? O kaya may existential crisis si Cantor. Tama, oo. Ako mababasa niyo yun. Hindi siya talaga, imagine mo na discover niya nung nabubuhay siya na merong infinitely many types of infinity. Alam niya kung ano yung pumatay sa kanya kay Cantor? Tinanong niya, gaano ka infinite yung number of infinities? Is that countable or uncountable? Diba sabi niya, may proof tayo that there are infinitely many infinities. Correct. May proof tayo nun. Ang tanong, gaano ka infinite yung set of all infinities? Is that countably infinite or uncountably infinite? Kasi mula ito yung countable. Lahat ito uncountable na. No? How about the number of infinities? Is that countably infinite or uncountably infinite? The truth is, ito yung question na kinakatakutan ng lahat ng nag-aaral ng set theory, because that question cannot be answered simply by a yes or a no. In fact, it can be proven that it cannot be proven. Oh my gosh, paano ba sasabihin yun? It can be proven that that question cannot be answered by the axioms of set theory. Sabihin yung axioms of set theory na meron tayo is not, the set of axioms that we have in set theory cannot answer that type of question. So we cannot objectively answer it by a yes or a no, because it's not a yes or no question anymore. Kumbaga kasi sa math, hindi tayo sasagot ng yes or no kung wala tayong proof, di ba? We don't have a proof that it is a yes, and we don't have a proof that it is a no. And we have a proof, but we have a proof that we cannot answer that. Yun yung sinasabi nila na walang perfect na mathematical system. Kahit anong axiomatic system ang inventuhin mo, kagaya ng pagiging axiomatic ng set theory, kahit na anong system ang inventuhin mo, laging may mag-e-exist na question that we cannot decide whether it is true or a false based on the axioms only. Yun yung Gödel's incompleteness theorem. It's actually a theorem, imagine niyo, na kahit na anong mathematical system, may dadating yung time na may question ka that cannot be answered by your system anymore. And this is one of those. Ang tawag dito, kung gaano ka infinite yung number of infinities, and tawag dito yung, ano man tawag dito? Oh my gosh, I forgot the name. Sasabihin ko sa inyo kapag naalala ko. Let's go back. Paubos yung time natin. Basta, from now on, alam nyo na mas marami ang mga real numbers sa mga integers, ha? Okay ba tayo doon? Okay. So they cannot be isomorphic kasi they have different cardinalities although they are both infinite. Okay? All right. So before we continue, magpo-pause muna tayo for a break. It's 10:30. Break muna tayo ng mga ilang minutes. Ang gusto nyo, 10 minutes. Gawin nyo yung mga gusto nyo gawin for 10 minutes. Pause ko muna recording. Next lesson na tayo pagbalik. Subgroups na tayo. Okay? I'm going to pause the recording. Okay. Diba in mathematics, just like sets, ang mga sets may mga subsets. No? Ang mga groups, naturally, ay may mga subgroups. No? Parang ganun yung analogy. Pero kapag sinabing subgroup, it is more than just a subset. It is a subset that is itself a group. Parang you can imagine that these are smaller groups that can be found inside a larger group. Now, sometimes kasi, especially when the group is large in abstract algebra, sometimes one strategy to study the group is to consider the subgroups first. No, aralin muna natin yung mga subgroups. Then eventually we can say some behavior, some pattern that we can say about the mother group. No, that's why it is imperative to talk about the substructures that can be found within a group. Okay, so here G is a group and H is a subset of G. Okay, this, as always. So this subset H will be called a subgroup of G, and write the following. No, ang basa natin dati dito when you were younger, less than or equal. But of course, hindi natin ito babasahin ng less than or equal kasi in the first place, in context, out of context siya. Si H kasi at saka si G, hindi naman mga numbers. They are sets, di ba? So, walang sense kung babasahin nyo itong ang tawag nito, less than or equal. So, in context, ang basa dyan, H is a subgroup of G. Now, ano yung mga conditions para pwede natin tawaging subgroup si H ni G? Tatlo. Tatlo ang kailangan yung i-check, okay? Ano yung tatlong yun? Number 1. First of all, dapat kung ano man yung identity element ni G, dapat siya yung unang-unang naroon sa H. So you can think of it as ito yung G, ito yung H. So ang unang-unang element na nasa H, dapat yung identity ni G. Hindi pa pwedeng yung identity ni G nasa labas ni H. Otherwise, H is not a subgroup, di ba? Okay. Second, H must be closed under multiplication. Meaning to say, kapag si A nasa H, si B nasa H, well, natural na yung A times B nasa G kasi they are elements of G, di ba? Ang problema, baka kasi yung AB wala doon sa H. Ang gusto natin, yung product ng AB nandun pa rin sa H. Okay? Para maging binary operation, ibig sabihin, ang sinasabi ko dito sa condition number 2, kung ano man yung operation ni G, it is also a binary operation on the subset H. Kasi kung anong, kapag kumuha ng dalawang inputs coming from H, yung product mo is still an element of H. And last but not the least, closure under inverses. When you say closure under inverses, dapat lahat ng mga bagay na nasa H ay may inverses na nasa loob din ng H. Kasi kung ang tanong, lahat ba ng elements na H may inverse? Yes, kasi they are elements of G as well. And G is a group. So lahat talaga ay may inverse. Ang tanong na lang dito is no longer the existence of inverse. Rather, kung yung inverse ba ay nandoon din sa loob ng H. So gusto natin, yung A inverse nandyan din sa loob ng H kapag si A ay nasa H. These three conditions make H a subgroup of the group G. So tatandaan niyo ha, the identity property, the identity must be an element of the subset. The subset must be closed under multiplication, and the subset must be closed under inverses for it to be called a subgroup. Okay? Natatandaan nyo ba? Identity, closure, and inverses. Closure for inverses. Yun yung mga yung tatlong kailangan nyo i-check. Ito yung tinatawag ko minsan na subgroup tests kasi kailangan mong i-perform yung mga tests na ito to determine whether a given subset is a subgroup. Did you understand? Now, before I continue, let me tell you as a remark that under this definition, if H has these three properties, then you can say that H is a group itself under the implied operation in G. What does that mean? It means to say that kapag itong tatlong conditions na tayo nasa-satisfy, the subset H is also a group itself under the operation of G. Kumbaga yung operation ni G, nire-restrict mo lang yung definition niya doon sa H. Why will it be a group? First of all, associative ba siya? Yes, kasi hiniram mo lang naman yung operation ng G. In the first place, G is a group, so its operation must be associative. Kaya kung hihiramin mo lang siya at gagamitin mo siya kay H, associative na yun. Second, may identity element ba? Yes, sabi no number 1. No? Number 3, may mga inverses ba yung mga elements ng H? Yes. Yung pangalawa, yung closure, tinatest lang naman natin yan just to make sure that the operation ng G makes sense in H. Naintindihan nyo? Pag kumuha ng dalawang elements ng H, sure tayo na yung product ay nasa H. Okay? Naintindihan nyo ba itong remark na ito? Okay. Number 2 remark is the fact that kapag si GI group, ang unang-unang mga subgroups niya na automatic ay yung sarili niya. No? Si G is a subgroup of itself as any set is a subset of itself. Correct? In fact, si G yung pinakamalaking subgroup ni G. Kung may pinakamalaking subgroup si G, ano naman yung pinakamaliit na subgroup ni G? Ano yung minimal? Diba? Hindi pa pwedeng empty ang isang subgroup kasi first of all, yung E ay dapat nasa H. Ang tanong, kung si E lang ang ilalagay ko sa isang subset, magiging subgroup ba yun? Yes, kasi kapag yung set mo, E lang ang laman, closed na siya under multiplication kasi ang E times E ay E. Diba? Second, closed din yan under inverses kasi ang E inverse is itself. Kaya yung singleton that contains the identity is also a subgroup and it is called as the trivial subgroup. Pag narinig niya si Sir sinasabi, the trivial subgroup, what I mean by the trivial subgroup ay yung subgroup that contains only the identity. Trivial. The word trivial means parang sa Tagalog, parang ano to, walang kakwenta-kwenta. Diba? Pero hindi yan walang kwenta talaga, no? Kasi it's still a subgroup. Yun nga lang, sometimes it's not useful to think about it kasi sa totoo, ang mas mahalaga sa atin are the subgroups that are smaller than G but bigger than the trivial subgroup. Okay? So let's consider the following. We know that under the ordinary addition, the real numbers form a group. Okay? Now, which of these subsets form a subgroup? So, i-check natin isa-isa. How about the set of integers? Check nga natin isa-isa. Ano yung kailangang i-check? Identity. Ano bang identity ng R? Ano identity ng R under addition?
0.
Very good, 0. Is 0 an element of Z or is 0 an integer? Diba? Oo naman. Diba? Pag nag-add pa ako ng dalawang integers, do I get another integer? I think so. Diba? Okay. Ano bang ibig sabihin natin ng inverse in the context of this group? Kasi addition tayo. No? So, ang inverse natin ay negative. Ang tanong, ang negative ba ng mga integer pa rin? Yes. Kaya si 1 is a subgroup of R. Yung I mean, the set of integers under addition forms a subgroup of R. Question. How about the second subset? It's the set N0. Ang isip ko na N0, it's the natural numbers including 0. Is this a subgroup under addition of the real numbers? I'd like you to answer me categorically, yes or no, in the
Yes,
chat
po.
box. Yes?
No.
Naku, may nag-no, may nag-yes. So ano talaga tayo? Sige, yung mga nag-no me, I know why not. Would like to answer why not.
Hindi po bilong yung inverses sa set na yan.
For example,
The -1 or
yan,
negative.
okay. Halimbawa, ang inverse ng 1 under addition ay -1. It's not found in N0. Totoo, may negative yung 1 in the real number line. Pero remember, yung inverses na tinutukoy natin dapat nag-exist doon sa subset. Kaya itong example number 2 is not a subset of R. Alright, let's now consider example number 3. How about the set of even integers only? Is this a subset of R? Categorically, yes or no? Yes, no? Check natin isa-isa. Kasi una, yung identity ng R, which is 0 under addition, is even. 0 is even. You must know that, okay? Second, the sum of two even integers is also even. Last but not the least, the negative of an even integer is also an even integer. So these three tests are satisfied, therefore it is a subgroup. How about the set of odd integers? Is this a subgroup of R? Yes or no?
No.
Obvious ito, no? Why not?
Add plus add is equal to even.
Odd plus odd is equal to even. Yes, correct ka dyan. Ang sum ng dalawang odd ay even, so it's not closed. Pero ang pinakamadaling, siguro ako, una ko napansin, yung wala siyang identity element. Sorry. Yung identity element in R is missing in F. Correct. Very good. Pero I mean, that's also a valid answer, no? Yung add plus add is equal to even. Although satisfied niyo yung closure for inverses. Ang negative ng add integer, add pa rin. Diba? Pero I mean, ang kailangan kasi dito sa definition, kailangan all of these three are satisfied. Hindi pa pwedeng dalawa lang, hindi pa pwedeng isa lang, dapat tatlo silang satisfied. Isa dyan ang hindi mo masatisfy, hindi na pwedeng tawaging subgroup. Tatandaan nyo yan, ha? Okay. Alright, let's consider another example. Consider the set H. What does H contain? H contains the integer powers of 2. When I say integer powers of 2, I mean these are 2 to the 0, 2 to the 1, 2 to the -1, 2 squared, 2 to the -2. You get what I mean to say? Ayan yung mga integer powers ng 2. And when they are all expressed as fractions, you see that they are 1, 2, 1/2, 4, 1/4, 8, 1/8, and so on. So alam natin precisely kung sino yung nasa H, sino yung wala. No? So let us kind of prove that H is a subgroup of what? Of R star under multiplication. Ano nga yung R star? Ito yung non-zero reals, di ba? Under multiplication. Under multiplication tayo. Hindi tayo under addition. Kaya natin tinatanggal yung 0 kasi Yeah, under multiplication nga kasi tayo. Because 0 will not have an inverse under multiplication. That's why we remove it in the set. Okay? All right. So, consider the subset consisting of the integer powers of 2. Prove that it is a subgroup of R star. So, how do you do the proof? Let's say, you're asked about this in the exam. Anong gagawin niyo unang-una? First of all, check there are 3 steps, di ba? Check the identity. Okay? The identity element of R star is under multiplication, ang identity element ay 1. First of all, sulat nyo, first of all, 1 is 2 to the power of 0, therefore an element of H. Okay, yun yung una. Next, closure for under multiplication. Multiplication tayo, no? So let's take 2 elements in H, let's say A and B. Okay? Being elements of H, meaning to say si A ay power of 2, si B ganun din. Lagay ko dito for some integers R and S. Do you agree? No, kapag si A at si B ay elements ng H, dapat ang itsura nila mga powers of 2, correct? Now, if I multiply A times B, what do I get? I get 2 to the R times 2 to the S. But what do I mean by that in algebra? That's 2 to the power of R plus S. In short, the product AB is another power of 2. Therefore, AB is in H. That proves closure of H under multiplication. Last but not the least, closure for inverses. Take any element A in H. Then again, A being an element of H means A is a power of 2 for some R in Z. Thus, if I now take the inverse, ang inverse natin dito ay reciprocal talaga, di ba? Kasi multiplication. But we know from algebra very, very well that this is 2 raised to the power of minus R. So again, A inverse is an integer power of 2 because minus R is an integer, therefore an element of H. All of this make a proof for the fact that H is a subgroup of R star. Naintindihan niyo kung paano ginagawa? So normally, how many steps do we need to take? How many steps did we have to perform para ma-prove na si H ay subgroup? In general, there are 3. That's why yung definition natin sometimes is called as the 3-step subgroup test. The truth is, sige na, hindi ko na kayo ipapahirapan. The truth is, there is a 1-step subgroup test. Ito kasing 1-step subgroup test na ito, you only need to perform 1 step in order to prove that H is a subgroup. Basahin natin yung 1-step subgroup test. So sabi, let H be a non-empty subset of a group G. So dapat si H ay non-empty, okay? Then the following are equivalent. H is a subgroup of G if and only if, ano yung condition? Kailangan for all A and B in H, dapat yung product na A, B inverse is in H. Did you understand? Kailangan mo lang i-check na kapag kumuha ng, ang gagawin mo lang pala, let A and B be in H. Ang ipoprove mo lang yung A, B inverse dapat mapunta sa H. Pag nagawa mo yun, that will suffice as a proof for the fact that H is a subgroup of G. Isang step lang. Wala ka nang kailangang i-check na kung ano-ano. Naintindihan niyo? Okay. Why is this true? Ipaprove muna natin yung 1-step subgroup test before we can apply it. Okay? So, the theorem is an if and only if statement. So, once again, there are 2 parts of the proof. I think this part is the trivial one, no? So assume H is a subgroup of G. let A and B be elements of H. So I think isulat ko dito para makasave tayo ng space, okay? Let A and B be elements of H. Okay? Since H is a subgroup of G, yung B inverse dapat nasa H din kasi si B ay nasa H. Kaya dapat yung inverse niya ay nasa H. Also, because of the closure property in H, si A nasa H, si B inverse nasa H, so therefore, dapat yung AB inverse nandoon sa H. Done. Tapos na tayo sa unang direksyon. Itong pabalik ang mahirap. Kasi, here we are assuming that for all AB in H, AB inverse is in H. Kunwari yan ay totoo. Ang kailangan nating ipakita in this case is the fact that H is a subgroup of G. Hindi assumption yung pagiging subgroup. No? It is something that we need to prove. Because by definition, there are 3 steps to prove that H is a subgroup of G. Kailangan natin i-prove yung tatlong conditions na yun ay nasa-satisfy. Okay? Did you understand kung anong gagawin ni sir? Tatlong conditions na yun kailangan. Ano yung tatlong conditions? Okay, yung identity ni G dapat nasa H. Number 2, closure property for H. Number 3, dapat closure for inverses. Okay? So, where do we start? Where do you think we should start? We show that these 3 conditions are satisfied given that this is true. I-underline ko yung hypothesis na tinatawag at yung hypothesis natin, okay? Alright. So, given that hypothesis or assumption, how can we prove that H is a subgroup of G? I don't know, but let's see. First, dapat ma-prove natin na yung identity nasa H, no? Okay. Paano natin mapaprove yun? Nako, iisipin natin yung mabuti. Ganito. Sabi sa assumption, si H ay non-empty. Okay? So may element siya. Hindi nga lang natin alam kung sino. Since H is non-empty, we may take an element, say, X. Kukuha lang kahit anong element niya. Kunwari X. Okay? Ang gagawin ko, let A and B be both equal to X. Kung sino man yung X na yan. Tama? Ay, walang tama. Tingnan nyo. By hypothesis, kung i-apply ko yung hypothesis sa case na ito, ano sabi ng hypothesis? Yung AB inverse, kasi yung A and B parehas X, nasa H yun. So, dapat yung AB inverse nasa H. Kaya lang sino ba si AB inverse? Siya si XX inverse, kasi siya yung, si A at si B ginawa kong X. But what is XX inverse? It is E, di ba? So, ang na-prove natin is that si E, yung identity element ni G, ay nasa H by using the hypothesis. So, remember, the hypothesis is true for as long as A and B are elements of H. Ang ginawa ko dito, kumuha ko ng kahit na sinong element ng H because I know that it is not empty. I let A and B be both equal to X. Then apply the hypothesis on A and B. Naintindihan ninyo? Sometimes you have to think backwards na in order to prove whatever you want to prove. Now that H now has the identity, anong susunod? Closure? The truth is, yung definition natin, may number lang. Anong issue mo na may number lang? The truth is, doon sa definition, may number na 1, 2, 3 yan, but that's not really in particular order. Wala naman talaga number dyan na dapat yan yung sunod-sunod. ang sa palagay ko dapat unahin niyo yung number 1. Itong 2 and 3 pa pwedeng mauna yung kahit sino dyan. Kasi yung number 1 guarantees you that H is not empty. Kaya yun yung unang-unang dapat ginagawa. Pero yung 2 and 3 pa pwede yung kasi mas madaling i-prove yung number 3 kaysa sa number 2 for me. Kasi number 3, isang element lang ang involved. Whereas yung number, dalawang elements ang involved. So let me prove number 2 first. 3, sorry. Closure for inverses. Okay. Now, let A be in H. Ipoprove ko na yung A inverse ay nasa H din. How do I do that? To do that, mali ako eh. Kasi dito, yung A and B variables, okay? Gamit tayo ng ibang element. Huwag na tayong gumamit ng A. Kasi yung A ay ginagamit na natin di ba? So let's take another variable, let's say just X. Anong gusto yung letter? Yung X ginagamit na natin eh. Niyot ng buhay, Diyos ko day. Anong gusto yung letter? O H na lang. Okay? Let little h be an element of capital H. I need to show that the inverse of H is in capital H as well. So this is what I do. Let A be E. This time, let A be E. And let B be H. Again, by hypothesis, ano sabi ng hypothesis? AB inverse must be in H. But what is AB inverse this time? AB inverse this time is EH inverse. But what is EH inverse? That is H inverse. So, ang na-prove natin is that whenever H is in capital H, yung H inverse ay nandun din sa capital H. Did you get that? Kung paano ginamit itong hypothesis. Okay. Finally, anong pangatlong step? Finally, naku, maubusan tayo ng space. Closure for closure property. So let me just copy this. Wait lang. Paste. And then, clear ko to. Dito ko nasusulat yung finally para hindi ko nabura yung nakaraang page. Okay. Finally, showing closure, kukuha ko ng dalawang elements ng H. Let H and K be elements of H. I need to show that HK is an element of H. Paano? Ganito. Already, we know that, what do we know? K inverse is in H. Kasi, paano ko nalaman yun? Tapos na tayo mag-prove ng pangalawa. Ito yung unang part, di ba? Ito yung unang part. Okay? Ito yung pangalawang part. Using the second part, we already know that H is closed under inverses. So ngayon, kung sinabi ko na si H and K nasa H, alam na natin na si K inverse nasa H kasi we already know that H is already closed under inverses. Okay? O, ganito. Ay, sorry. Let A be H and B be K inverse. By hypothesis, once again, ano sabi ng hypothesis? Sabi ng hypothesis, dapat yung AB inverse nasa H. But what is AB inverse? AB inverse is is H, K inverse inverse. But what is HK inverse inverse? That's HK. So in the end, I was able to prove that whenever H and K are elements of capital H, the product HK is also an element of H using the hypothesis. Now, all of this prove that H is a subgroup of G. And we are done with the proof. Kaya mula sa araw na to, alam nyo na yung one-step subgroup test. Instead of doing 3, you can just use 1. Pero alam nyo sometimes, no, kahit na alam ko tong one-step subgroup test, the truth is, ano bang katotohanan? Ginagawa ko pa rin yung 3 steps kasi para sa akin lang, no, ito yung personal preference. Para sa akin lang, kapag chinek ko isa-isa, yung identity tama na sa H. Close siya under multiplication. Close siya under inverses. Nararamdaman ko or damang-dama ko na yung subset na yun ay talagang subgroup. Nakikita mo kasi kung ano yung identity, di ba? Kung close ba siya under inverses. Mas nadadama ko kesa yung nag one-step subgroup test ka. Yes, you might be correct that H is a subgroup, pero parang hindi kumpleto yung pagkaunawa ko pag hindi ko ginawa yung tatlong step. Anyway, it's just a matter of preference and hindi ko kayo pinipilit na gawin yung 3 step. Kung gusto nyo gawin yung 1 step, okay lang. Yun nga lang, tatandaan nyo na dapat yung H ay ma-prove nyo munang non-empty bago nyo i-apply ito. Okay, dapat sure kayo na may laman yung H bago nyo i-apply. Meron lang akong i-remark sa ito na naman tayo kasi in the theorem, in the theorems, I always use the multiplicative notation. But if let's say the operation of the group is addition, yung AB inverse does not really look like AB inverse, ha? Kung addition yung operation sa G, ang meaning ng AB inverse ay iba. Ang meaning talaga nun, A plus the additive inverse of B. Kumbaga, kapag ang operation addition, ano ba, numbers, ang meaning nito, subtraction. Subtraction yan sa algebra, di ba? Ito, kung multiplication, parang division. Intindihan nyo? Closure for division will imply that H is a subgroup. Or kung additive operation na meron tayo, closure under subtraction will imply that H is a subgroup. Nice na? So this makes use of subtraction and division. Parang subtraction and division ito. Naintindihan nyo ba si Sir dito sa remark na ito? Just in case that the group is additive in nature, let's say addition ang ginagamit instead of simple multiplication. Ito ang meaning ng AB inverse. Hindi yan AB inverse palagi. Yung ibig sabihin natin ng B inverse dito tsaka ng AB inverse, product ng A and B inverse with respect to whatever the operation is. Kaya kung operation mo addition, ito yung meaning niya. Okay, so let's exhibit. Pakita nga natin yung one-step subgroup test sa example na ito. Halimbawa, for each natural n, tawagin natin NZ. Anong laman ng NZ? Ang laman ng NZ ay yung mga NK, where K is an integer. So for example, no, just as a matter of example, pag sinulat pala ni Sir na 2Z, ang laman nito yung mga 2K. In other words, yung mga even integers. Okay? So pag sinabi ni Sir na 13Z, ang laman nito yung mga 13K. Ano yung 13K? 0 plus minus 13 plus minus 26 plus minus 39, etc. Yun yung meaning natin nun, ng mga bagay niyan. And in general, pag NZ, mga NK, yun yung 0 plus minus N plus minus 2N and so on. Alright? Ipoprove natin in this example that this set NZ is actually a subgroup of the group Z. Na katulad nito. So wala kayong binanggit na operation ng Z. Anong operation ang gagamitin ko? Now, it is quite clear from the context, dapat it should be clear from the context that I am talking about Z under addition. Kasi Remember, si Z ay hindi naman group under multiplication. Diba? For example, si 2 kasi walang reciprocal sa Z. So because it's not a group under multiplication, we will not think of it as a group under multiplication. Instead, ang automatic or ang implied operation nito ay addition. Okay? So under addition, yung NZ, prove natin to be what? What? A subgroup of Z, an additive subgroup. So paano natin ipoprove? I-apply ko yung one-step subgroup test. But first of all, ito na naman, ang hilig sa first of all, no? Yung NZ, meron niyang laman, hindi yan empty, no? Since, sino-sino yung sure na palaging element ng NZ? Yung 0, di ba? 0 is n times 0. So it's in NZ. Okay? So we now apply the one-step subgroup test. How? We will take two elements in NZ, let's say A and B. In your mind, what do you need to show? I need to show that A minus B, in this case, A plus minus B means A minus B, is an element of NZ. Kailangan ma-prove ko yan. How can I prove that? Ganito. Si A, bilang siya ay nasa NZ, it means to say that A is in the form of NK for some K. Agree? Agree? Also, so maybe I will put a sub 1. Kasi I will consider another element. Let's say B. B is in NZ, so I can write B as NK2 for some K2 in Z. Tama? Tama ba? Nakakasunod? Okay. Now, if I do A minus B, ito yung one-step subgroup test or A plus minus B. In this case, it will mean NK1 plus negative NK2. As you can see, this can simplify to NK1 minus K2. Or I can say that this is NK, where K is an integer. Because it's the difference of K1 and K2. Medyo ayusin ko mabuti. Yan, sulit ko mabuti. Diba? Therefore, nasan yung A minus B? It is still in NZ. Tapos na. This proves that NZ is a subgroup of Z. Ito yung sinasabi ni Sir. Minsan, pag nag-a-apply ka ng one-step subgroup test, napuprove na naging subgroup siya nang hindi mo naramdaman. Hindi, well, personal preference lang naman. Personal preference ko pa rin yung 3-step. Kasi nga, damang-dama ko na subgroup siya, hindi kagaya na itong one-step subgroup test. Nagiging subgroup nang hindi mo naramdaman. Ay, may tanong si Sir dito. O di ba alam niyo yung NZ, mga multiples ng N sa number theory ang tawag dyan. Pag MZ, mga multiples ng M. Okay? May tanong si Sir. When is MZ a subgroup of NZ? Parang tinatanong natin, kailan yung mga multiples ng M, mga multiples of N din? Would like to answer? Check yung mabuti. I will give you an example. Halimbawa, 4Z contains the multiples of 4. And this is a subgroup of Z, ha? Subgroup ito. Okay. Nagkataon, lahat ng mga elements ng 4Z ay even. Therefore, si 4Z ay nasa loob lang ng 2Z. Okay? Pero for example, si 5Z, yan, si 5Z ay hindi subgroup ng 2Z kasi ilan lang yung even na nasa 5Z. May mga elements si 5Z na wala sa 2Z, halimbawa 5. So in general, when can we say that MZ is a subgroup of NZ? May sagot pala sa chat box yun. Whenever M divides N, tama ba yun? Check nyo mabuti. Here, 4Z is a subgroup of 2Z, but 4 does not divide 2. Ayun, baligtad. Ang sagot? Ano sagot? When N divides M. Baligtad ha? MZ will be a subgroup of NZ if and only if N divides M. Okay? Kaya nga, sometimes, halimbawa, yung mother group, no, ZZ, nasa loob nyo si 2Z, okay? Nasa ilalim ng 2Z si 4Z, si 8Z, yung mga powers of 2, and so on. Nandito si 3Z, okay? Tapos, si 6Z, for example, nandito yan sa loob ng 2Z tsaka ng 3Z. Kasi, 6 is both divisible by 2 and 3. Naintindihan niya? Sometimes we express the diagram this way. Tapos, sino yung nandito sa gitna ng 4Z at 6Z? Sino yung pinakamaliit na ang madidivide parehas ng 4 at saka ng 6? Pinakamaliit na integer na madidivide ng 4 at 6. Yan, nandito si 12Z. Nakukuha niya, nagigets niya yung vibe. Nandito si 5Z. Nandito si 15Z. May nakalimutan tayo. Nandito si 10Z. Ayan, may intersection pa yung dalawa na yun. Marami yan, no? Etc. Palaki ng palaki yung family tree. Yan yung family tree ni Z. Of course, I can never complete this diagram because, yeah, it's just, there are just infinitely many of them. Hindi natin makukuha lahat ng possible connections. Parang you can, yeah. Ang tawag natin dito, we call this the lattice diagram of subgroups. Yung parang family tree. Pag alam mo yung mga subgroups niya, you can draw parang family tree. Sino nasa ilalim nino, no, etc. Okay? Now, yung one-step subgroup test natin, kailangan yung gawin to, di ba? Isang test lang. There is an even better test, you know. Yun nga lang, yung test na ito ay nag-a-apply lamang for finite groups. Okay? Nag-a-apply lamang ito for finite groups. So let G be a finite group and H is a non-empty subset of G. Kailangan yung G mo finite, okay? Then, ano sabi? H is a subgroup of G if and only if H is closed under the binary operation of G. Yung galing, no? Yung isa, yung tatlo, yung 1, 2, 3 na test, pwedeng gawin mo na lang pala yung 2. Yung alam may condition ha, kailangan yung group mo ay finite. Okay? Kapag finite group lang ang tinitignan ninyo, kasi ang mga susunod na examples ko na mga finite na groups ko na, kaya nire-ready ko na yung theorem na ito para madaling ma-check. Kapag finite lang yung group, when you're looking at its subsets, para ma-check mo kung subgroup siya, kailangan mo lang i-check ay closure under the binary operation. Yun lang, wala nang iba. Naintindihan nyo? Hindi mo na kailangan i-check na yung identity nandoon. Hindi mo na kailangan i-check na yung mga inverses ay nandoon din. You only need to check for closure under the binary operation. Amazing, no? Bakit kaya? Sige, tingnan natin ito. Let's see. Once again, ito trivial. I mean, this is trivially true. Right? This is trivially true. Kasi kapag subgroup si H ni G, close talaga si H under the binary operation. So, let's move to the other direction, which is the non-trivial part. Assume H is closed under the binary operation of G. Anong kailangan natin prove? Pabalik na ay kailangan si H ay maging anong kailangan i-prove? Kailangan ma-prove na si H ay subgroup ng G. Okay? And how can we achieve that? Actually, gagamitin ko yung one-step subgroup test. So that by the one-step subgroup test, kanina, we only need to show that whenever A is in H, the inverse is also in H. Bakit magka-follow ito? Bakit ito na lang kailangan nating i-prove? Kasi kung closed ka na under inverses, tas closed ka pa under multiplication, magka-follow na for all AB in H, magka-follow na ng AB inverse nasa H. Kasi kung closed ka under inverses, si B ay nasa H, yung B inverse nasa H. Ngayon, kung si A at saka si B inverse nasa H, yung AB inverse nasa H na. At pag ito ay nag-hold, sabi ng one-step subgroup test, subgroup na si H ni G. Kaya ang kailangan, ang ipapakita ko, na-reduce ko na lang dito sa napakasimpleng bagay na to, closure under inverses. Once I was able to prove this, it's like proving the one-step subgroup test. And eventually, ma-imply nga na si H ay subgroup ni G. Naintindihan niyo ba si Sir? Bakit ito na lang? Bakit na-reduce na lang dito yung proof? Did you understand? Ito na lang. Kasi ito yung one-step subgroup test. Kung closed siya under multiplication and closed under inverses, pag pinagsama mo yung dalawang yun, may imply yung one-step subgroup test. Therefore, it will imply H is a subgroup of G. So, I hope that you get that. Meron ba kayong questions before I continue? Okay, wala? O, sige. So, let's start with the proof. We will take an element of H. Okay? We will consider cases. First of all, note that if A happens to be E, kung sakali, if naman ito, hindi ko sinasabi na si A ay E. Ang sinasabi ko, kung si A ay yung identity. Okay? Ano bang inverse niya kung sakali? Ang inverse ng identity ay ano? E. So, ang inverse ni A ay A. Kasi A nasa H. So, na-prove na natin na si A inverse ay nasa H kung si A ay identity. Okay? Paano kung hindi? Ito na. Assume now that A is not the identity. Ganito yun ha. Parang itong let A be in H ko, kinonsider ko yung dalawang case. Parang nagdalawang cases ako. Ang case 1 ko, A is E. Ang case 2, A is not E. Did you understand? Ganyan yung ginawa ko sa proof. Naka-paragraph form lang that you might find it confusing, pero basically ganyan lang yung ginawa ko. Nagdalawang cases ako. Okay tayo? Tapos na tayo sa case 1. Pag kasi si A ay E, ang inverse niya sarili niya, kaya talagang closed siya under inverses. Pag si A ay hindi E, ito yung challenge dyan. Okay. So, paano natin to magagawa? Okay, ganito. Consider the set S consisting of A and the positive powers of A. Okay? What can be said about this? What can be said about this set? First of all, since A is in H and H is closed under multiplication under the binary operation of G, these two facts will imply what? Si A nasa H. So, nasaan si A squared? Si A squared kasi, take note, ay A times A. Kasi A nasa H. Nasaan yung A times A? Si H ay closed under the binary operation. Assumption yun. Ano mangyayari? Si A squared nandoon din sa H. Tama? Sino pa? Si A cube nandoon din sa H kasi ang A cube ay tatlong A times A times A lang. Ang A to the fourth, apat na A times A times A times A. So, dahil close si H under the operation, nandun pa rin yan sa H. Kaya mag-follow, lahat ng mga positive powers na yan ay ano? Nasa H. In short, si S ay subset ng H. Tama? Okay. However, H is finite. Kasi si H ay subset ng isang finite na group, so it must be finite itself. Ibig sabihin, sa listahan na to, dapat there are infinitely many positive powers of A. Ibig sabihin, sa listahan na to na infinite, hindi yan magkakaiba-iba. Eventually, elements or powers has to repeat. Naintindihan ninyo? Hindi pa pwede magkakaiba yung mga yan, otherwise magiging infinite. So dapat lagay ko dito, so is S, okay? Ibig sabihin ng so is S, kasi si S nasa loob ng H, dapat si S then finite. Correct? However, H is finite, so is S. Diba? O, ano nga yung mangyayari? May magre-repeat dyan. Ibig sabihin, may dalawang positive powers dito. Ang magkaiba na exponent, pero pare sila ng value. Therefore, there are integers R and S. Say R is less than S, but A to the R is equal to A to the S. Kumbaga, dalawang positive powers ng A ang mag-i-equal eventually. Kasi finite yung H eh. That may mauulit dyan. Kunwari, itong dalawang powers na to parehas ang value kahit na magkaiba yung exponents. Ano mangyayari? Ito yung mangyayari, guys. Ang mangyayari ngayon, hence, A to the R minus S. Ano yung A to the R minus S? Saan equal yung A to the R minus S? Ay, mali. Dapat S minus R kasi I need a positive exponent. Ano yung A to the S minus R? Ang A to the S minus R is A to the S times A to the minus R. Diba? Ito yung A to the S, A to the R inverse. Saan equal to? Take note, equals A to the R tsaka si A to the S. So kung equal sila, saan equal tong product na to? Very good, identity. Kasi nga, equal yung dalawang to. Kaya if you multiply one with the inverse of the other, kung equal sila, identity lang yun. Okay? Okay, hindi pa tayo tapos. Hindi pa tayo tapos. Medyo mahaba-haba. Actually, hindi mahaba. Erase ko lang to. Alright, nasa na tayo? And continued. So, ang napatunayan natin, a to the s minus r is e. Ibig sabihin, si s minus r, di ba positive? Di ba kasi si r ay less than s, so ang s minus r ay positive. So, this is what we get. A to the s minus r is equal to e. Ibig sabihin, sa listahang ito, somewhere in this list, lalabas si e. Did you understand? Somewhere in this list, lalabas si e. But a is not e. But a is not e. Diba? Sa assumption yun. But a is not e. Ano mangyayari? Ibig sabihin yung exponent na to hindi pwedeng maging 1. Kung positive siya, dapat yung s minus r dapat mas malaki sa 1. Sabihin, it could be 2, it could be 3, it could be 4. Basta hindi 1. Kasi nga, si a ay hindi e. Kasi kung ang s minus r nag-equal sa 1, para mong sinabi ng a ay equal to e. Bawal yun kasi ang assumption is a is not e. Ano naman mangyayari ngayon, sir? Ang haba naman, no? Ito tingnan nyo. Therefore, a to the s minus r minus 1 is still in s. Kasi yung exponent na to, positive pa rin. Naintindihan niya, that is still positive. Ang laman ng s ay mga positive powers ng a. Correct? So, if I multiply a times a to the s minus r minus 1, what do I get as a product? What do I get as a product if I do this? Toss of exponent, a to the s minus r, which is equal to e. Correct? Correct. So, if two elements have products equal to e, have a product equal to e, how are they related to one another? If two elements multiply ko, lumabas identity, magkaano-ano sila? Very good. They are inverses of one another. So, the inverse of a is a to the s minus r minus 1, which is an element of s, sabi natin dito. But remember, S is a subset of H. Ayun na, tapos na. Therefore, kung si A inverse ay nasa S, therefore si A inverse ay nasa H. Ano na-prove ko? Na-prove natin na kapag si A ay nasa H, yung A inverse nandoon din sa H, which is what we wanted to show. Okay? Medyo mahaba yung proof, pero hindi naman, yeah. Therefore, we were able to achieve what we wanted to achieve. Therefore, H is a subgroup of G. Kaya tatandaan nyo, pag finite lang ang pinag-uusapan, you only need to check for what? Closure. Kailangan closed under the operation. Nice, no? Okay, sige. Gawin natin yan in practice. Determine which of the following subsets are a subgroup or subgroups of Z sub 6. Diba ang Z sub 6, ang laman 6. These are the elements 0, 1, 2, 3, 4, 5. Okay, under addition modulo 6. Now, which of these subsets form a subgroup? Number 1, is H a subgroup? Kailangan nyo lang i-check ay closure. Remember kasi, ito ay finite na case. Is H closed under addition modulo 6? Number
Yes.
1. Yes. How would you prove that? You have to present this table. Pag magpo-prove ng closure, kailangan may present yung table na ito. Kailangan walang lalabas na ibang element. 2 plus 2, 0. 2 plus 4, 2. Ay, tama ba yun? Ulit. Mali. 2 plus 2, 4. 2 plus 4, 0. 4 plus 0, 4 plus 0. 4 plus 4 is 2. Yeah, so closed. So H is a subgroup of Z sub 6. How about the set 1, 3, 5? Automatic na known na to, no? Kasi 0 is not an element of S. Remember, the identity must be first in the subgroup. So that's one reason why I said no. In fact, another reason could be ang 1 plus 3 ay 4. It's not an element of S. Ito yung nasa S, ito yung nasa S. Diba? Pero ang 4 wala sa S. So S is not a subgroup of Z sub 6. How about 0, 2, 5? Pag no ang sagot, you just need to present a counterexample. Pag yes ang sagot mo, you need to show the entire table. Okay? Naintindihan niyo ba? Kasi kapag no, counterexample. Pag yes, you need a proof. Kapag proof, kailangan lahat ng cases are what? Lahat ng cases dapat nandun. Yan. May sagot si Alistair. Sabi niya, 2 plus 5 kasi po ay 1 sa Z sub 6. Huwag niyo kakalimutan na in Z sub 6 yan, ha? Huwag niyo papakita sa mga kapatid niyong maliliit yan. Okay. Si 2 and si 5 nasa T, but 1 is not in T. Therefore, T is not a subgroup of Z sub 6. O diba? Mas madaling malaman ang pagiging subgroup kapag finite kasi you just need to check closure. Okay. Alright, so I have given you here the Cayley table for the Klein 4 group V sub 4. Okay, this is the Klein 4 group V sub 4, and I want you to list down all the subgroups of the Klein 4 group. Okay, syempre, because this is a group of order 4, we could have a subgroup of one element only. Yun yung trivial, no? Meron ka bang order 1 subgroup? Syempre, ang pwede lang, yung trivial na subgroup. Hindi ka pwede magkaroon ng singleton A. It will not be a subgroup kasi wala siyang identity, di ba? Correct? Laging subgroup ito, di ba? Tama ba si sir? Okay. Order 2. Meron bang order 2 na subgroup? Tingnan natin. Syempre, sa lahat ng subgroup na gagawin nyo, tatandaan nyo, laging automatic member si E. Okay? Tanong, pag sinama ko ba si A, sinarado ko subgroup yan? Yes or no? Closed ba ito under multiplication? Try natin. E times E is E. E times A is A. Correct? Pasok pa. How about A times A? E. Okay, pasok. So therefore, close ito. Therefore, ano yan? Subgroup yan. How about if I include B with E? Same thing na, because B times B is also E. Subgroup yan. Similar with EC. Okay? How about if I do AB? Can I take this as a subgroup? No. Diba? Kasi walang identity yan. Remember, si E ay laging present sa kahit na anong party. Okay? Yung identity element yan, yung class president. Order 3, may order 3 ba? Try natin. EAB. Closed ba ito? Is this closed under multiplication? Check nyo sa table. Siyempre, EA is A, EB is B, pero ang AB, ano yung AB? I see. Wala siya dyan. In short, pag si A at si B nandoon, dapat si C nandoon din, no? So, hindi. This is not a subgroup. How about EAC? Hindi rin kasi yung A times C ay B. Diba? How about EBC? Hindi rin. Wala na tayong ibang choice. Meron bang subgroup of order 3? Meron bang subgroup of order 3? Makita nyo? Pwedeng wala kang subgroup of a given order. Order 4, syempre, wala ka ng ibang choice, kundi yung V4 itself. So this is now the complete list of subgroups for the Klein 4 group. Now, because we have listed down the complete set of subgroups, pwede na natin gawin yung family tree o yung tinatawag nating lattice diagram for subgroups. Nilalagay natin sa pinakamataas yung pinakamalaking group, which is subgroup, which is V sub 4. Tapos, ilalagay natin pababa habang papaliit ng papaliit yung subgroup. Yung mga subgroups na magkakasing order, dinodrawing natin silang magkaka-level. Ano yung sabihin ni sir? Ito, yung EA, ka-level niya yung EB, ka-level niya yung EC. Magkaka-level sila, no? Baga, huwag kayong mag-inarte, pare-parehas lang tayong tig, dalawa. Tapos, syempre, yung pinakamaliit, CE. Tapos, lalagyan natin ng guhit to illustrate that they are subsets of B. Tapos yung E naman, subset naman siya nung bawat dalawa, kaya lalagyan mo ng ganyan. Kaya ang lattice diagram of subgroups para sa Klein 4 group, ganyan ang itsura. Okay? Ang itsura ng Klein 4 na family tree, ganito. Did you understand? Ganyan yung family tree nung Klein 4. Iba-iba ng group, iba-iba ng family tree. Nice, no? Sige nga, as an exercise, gawin nyo nga yung family tree ng Z sub 6. Kaya nyo gawin yung ilista lahat ng mga subgroups ng Z sub 6. Exercise yan, ha? Sige, gawin nyo sa bahay. Alright. Next theorem. Oh my God, magta-time na. Wala pa tayo na di-discuss. We are slide 19 out of 35 for the week. Dapat ito matapos this week eh. Anyway, we cannot, of course, hindi natin ito pwedeng pilitin. But let's see what we can do. Ano sabi ng theorem na ito? Let HI, the collection HI, be what? Let this be the collection, be an arbitrary collection of subgroups of G. Sabihin, yung mga HI na tinutukoy dito sa collection na ito, they are all subgroups of G. Anong conclusion? Their intersection is another subgroup. Sa makatuwid, ang sinasabi nito, if you have a bunch of subgroups of a group G, ito yung, this is how I look at it, no? Let's say ito yung subgroup H1, ito yung subgroup H2, ito yung subgroup H3, kahit ilan sila. Kahit na 39 pieces sila or kahit na infinitely many, kahit na ilan. Kasi nga arbitrary ito. Sino magsasabi kung ilan ang laman ng collection na yan? Yung index set I. Ang tawag dito sa I, call that an index set. Siya yung nagsasabi kung gaano kadami yung nariyan sa collection na yan. Okay. Anong conclusion? Yung intersection daw na yun, yung maliit na yun, kung saan sila nag-meet lahat, no? That is the grand intersection. Normally, this is how we write it in, using the simple intersection. But you can also write this as the intersection of the HI, in this case, I from 1 to 4. Kasi meron ka lang 4. In general, ganito siya sinusulat kung if you want to make it arbitrary. Okay? Yung intersection daw na yun, palaging subgroup. Nice, no? Sabihin, pag meron ka ng ibang examples ng subgroups, just take their intersection will form another subgroup. Okay ba yun? Maintindihan ba yun? So why is this true? Okay. First of all, why is the intersection always not empty? Ito na naman yung first of all. First of all, why is the intersection non-empty? Kasi sa lahat ng mga tests na meron, ang unang chine-check, dapat non-empty yung subset na yun, di ba? Okay. Bakit non-empty yung intersection? Ba't hindi mauubusan ng laman yan? Ayan, very good si Ron. Sabi niya, because the identity E is present in all of the subgroups. Yes, correct. First of all, E is in the intersection since E is in HI for all I in H. Remember yung intersection na ganito ang itsura. Pag nakakita kayo ng ganito sa math, ang laman talaga niyan, lahat ng mga X, so that X is in HI for all I. Okay, for all. Now, let me emphasize here, intersection stands for all. Kapag union naman, anong pinagkaiba ng union sa intersection? X is in HI. Ang pinagkaiba dito, for some. Okay? For some I in I. That's the main difference. Pag intersection for all, sabihin dapat nangyayari yung X present sa lahat. Pag union, if X is present in some HI, need not be in every HI, then X is already in the union. Kumbaga mas maluwag makasama sa union kaysa doon sa intersection. Normally, masikip ang intersection, maluwag ang union. Naintindihan ninyo? Okay. Okay, since E is in HI for all I, then E is in the intersection. So therefore, we can be sure that this intersection cannot be empty. Now, I can now use the one-step subgroup test. Let me pick two elements A and B in the intersection. This is how we perform the one-step subgroup test. Now, A and B being in the intersection, that means for all I, A and B are in HI. Yun lang naman ang sabihin nun. Since HI is a subgroup of G for all I, then by one-step subgroup test, kung si A and B ay nasa HI at subgroup yun, dapat yung AB inverse nasa HI for all I din. Di ba? Therefore, si AB inverse, nasaan? Nasa intersection ng mga HI. Therefore, by one-step subgroup test, once again, the intersection is a subgroup. O di ba madali lang yung proof? Kasi nga, meron ka ng mga subgroup tests na yan. Tsaka nauunawaan natin kung anong laman ng intersection. Remember that, okay? Halimbawa, consider the subgroups 4Z and 6Z of Z. I want you to determine the intersection of 4Z and 6Z. What is that? Ano to? Ito yung 0, plus minus 4, plus minus 8, plus minus 12, plus minus 16, blah, blah, blah. 6Z, 0, plus minus 6, plus minus 12, plus minus 18, plus minus 24, blah, blah, blah. To get the intersection, what do you need? Okay, of course, those which are common. Kailangan mo ito, yan. Bibilugan ko, no? Ayan. Ayan. So, lalagay mo dito plus minus 12. Kailan sila susunod mag-intersect?
Positive, negative 24.
Ganyan. Kailan susunod?
36.
May pattern. Yeah. So, the result is actually the subgroup 12Z. Diba? These are all the multiples of 12. Hindi pa familiar ito. Ginagawa niyo to dati when you were a little younger. Ginagawa niyo to dati. Anong tawag niyo doon sa 12? Correct. Kasi ang kasunod niyan, correct, tama kayo dyan. LCM. No? LCM. Ang susunod niyan kasi, tatanungin ko kayo in general. Kapag nag-intersect yung MZ tsaka yung NZ, ang intersection niyan LZ. Ang tanong, anong relationship ng L sa M at saka sa N? Correct. L is the LCM of M and N. Now, my question is, how about the union of 4Z and 6Z? Is that a subgroup of Z? Kasi tapos na tayo sa intersection. How about the union? Paano yung union? Pagsasamahin mo lang, no? So, lalagay mo yung multiples ng 4. Okay, lagay natin multiples ng 4. Isasama natin yung multiples ng 6. Do not forget. Yan. Yan yung 4Z union 6Z. Kaya ang itsura nun. Is this a subgroup? I don't think this is a subgroup. You know why? Kasi 4 plus 6 is 10. And 10 is not in the union. Diba? Si 4 nasa union, si 6 nasa union, pero yung 4 plus 6 which is 10 is not in the union. So, ang tanong, is this union a subgroup? Of course, the answer is what? Yes or no? Yes or no? Hello? Naririnig ba ako? Parang nawala ako. Hello, am I still connected? Oh. So, ang sagot dito, yes or no? No. Okay, tatandaan yan ha. In general, kaya hindi naging theorem yung union kasi the truth is, if H and K are subgroups of G, the union H union K may not be a subgroup of G. That's one of the moral lessons. Sige. So remember, we are in slide 20 out of 35. I'm going to stop the recording at this point and we will continue next time. Okay?